Hey all, I've got a bit of a project update for you this time. It's September, which means it's the Homebrew Robotics Club's Challenge Month Phase 3. The club has a number of defined challenges, but the classic HBRC challenge is the TABLEBot challenge. And since y'all know that I like old computing hardware, I built this. The Junkbot. Lovingly named after the fact that every piece of hardware in here should have been sent to e-waste in the decade before the last one. So, if you don't know what the TABLEBot challenge is, it's basically a set of objectives for a robot that navigates around a table. Phase 1 is to build a robot that can go from one end of the table to the other and then back again. Phase 2 steps up the difficulty and has your robot find an object and push it off the table. And finally, in Phase 3, rather than just pushing the object off of the table, you have to place an object in a shoebox mounted at the end of the table. The general theme of the whole challenge is that it can be subtly complex. HBRC created the TABLEBot challenge all the way back in 2003, so the general theme for Junkbot is to solve the challenge with the hardware that I had when I first heard about it, which I think was an issue of Servo magazine in late 2005. So sticking with the theme of hobby robotics hardware from at least 20 years ago, I've built Junkbot out of an old Parallax Boe-Bot. Boe-Bot was an educational kit aimed at high school students in the early aughts, and paired one of Parallax's basic stamp microcontrollers with a small servo-driven chassis. The kit came with a pack of electrical components which you could use to do various simple robotics experiments, such as light or dark seeking, or even collision avoidance. Though by today's standards, the basic stamp is an extremely primitive microcontroller. They pretty much disappeared overnight when the Arduino came out because it was better in every conceivable way. The first thing you'd notice is that the basic stamp has no hardware peripherals. Every interface is bit-banked. You don't have any timers or interrupts. So if you're, say, generating the PWM outputs to control the servos, you can't listen to data packets coming in from the camera. You may have noticed the robot makes pulsing sounds as it's driving, and those are the intervals when the stamp is receiving data from the camera and can't send the servo control signals. I don't want to be too harsh on it though. At the time that it came out in the 90s, it was revolutionary for the hobby and education market. We pretty much take for granted that we can just plug a USB cable into an Arduino or an inexpensive SWD programmer into an ARM board to program our projects. The compilers are also typically free in the hobby market, and this was far from how it was back then. The fact that all you needed was a serial cable and a small free IDE from Parallax was rather unheard of. So the major sensor that probably stands out is the CMUcam, version 1. I use it for detecting blocks on the table and finding the colored target on the shoebox. It's mounted on a tilt mount so that it can look down when trying to position the block in the gripper and look up when it's trying to find the box. None of the tools for interacting with the CMUcam work on modern computers, so I ended up having to write my own, which ended up being a fun exercise because using the frame dump interface was something I never actually did back then. And yeah, that's the real-time frame rate over the camera serial interface, several seconds per frame. When running on the robot, though, it's capable of tracking an object in a 80 by 143 pixel window at 17 frames per second. The horizontal resolution is really 176, but every other pixel is dropped because of the camera's processing speed. And don't get me started on how horrible the color accuracy and reproducibility of these early CMOS image sensors is. There's a reason I did all this testing at night with constant lighting. And next we've got the cliff sensors, which really are just old sharp IR distance sensors and were probably found in the automatic faucets of the day. They're really straightforward to use as they output a voltage that is related to the measured distance. I actually remember a fun post back in the day about interfacing these to the LEGO Mindstorms RCX. Rest in peace. These four are used to detect the edge of the table, and the two forward-facing ones are used to avoid obstacles and to align with the shoebox. As I said before, the basic stamp has no peripherals, which means that it has no analog to digital converters, so all the distance sensors are plugged into this SPI ADC, which is an MCP3008. I'm not sure of the introduction date for this ADC, but the copyright on the datasheet goes back to the year 2000, and I know for certain there were at least single-channel SPI ADCs available back during the Basic Stamp's heyday because some of the Basic Stamp kits came with them. I'll also quickly note that I did replace the 4AA battery pack with a custom power board that uses 18650 lithium cells. It does use modern switching regulators to supply the 6 volts the Boe-Bot expects, but the battery and polarity protection is built in with period correct hardware. And now for the part that everyone is waiting for, and that is the demo. So we'll start with a simple setup for Phase 3. The block is in the center of the table, and the shoebox is at the end of the table. Junkbot goes and grabs the block, and then puts it into the shoebox. But this This doesn't involve the cliff sensors, so let's do a complicated setup where neither the block nor shoebox is in view at the start, and Junkbot has to hunt for them. So, thanks for watching, and if you have any questions or would like me to do a deeper retrospective on any of this hardware, let me know in the comments below. Also, if you're in the Bay Area, check out the Homebrew Robotics Club at hbrobotics.org. We meet at 7 p.m. on the last Wednesday of every month, and for those not in the area, you can join meetings through Zoom. We'll also have a booth at Maker Faire Bay Area this weekend, so maybe see you there.